very busy schedule. We first of all look back into 50 years of PCB history. We do also a future outlook. We talk a little bit about reliability, new PCB design, some research papers. We talk about 5G. We will visit the multi-layer factory Unimicron. And after that, we have a very nice celebration dinner in a castle. So looking out to be a very good conference program.
So welcome to the EIPC 50th Anniversary Summer Conference. 1968 was the year we started. It was billed as the year that changed history. You can see how this bonding works. In this case, every atom bonds to 4 other atoms and forms a really, really strong structure. I brought some diamonds as well.
Graphene is an amazing new material.
So first presentation is going to be from Walt Custer.
Right now, the world is growing all over. Virtually every large country is expanding. There's plenty of good things to look forward to. The Internet of Things is drawing a lot of interest. Here's a list of the top PCB manufacturing companies. It gives you a hit list of who to go after.
We'll take questions at the end with the panel.
We are forecasting an increase of the use of the SLP in the smartphone. The introduction this year of the SLP product is revolutionizing the PCB market.
When this happened, really the industry took its first major change with the manufacturing techniques for HDI. We provide the chemistries that let you make these PCBs. These are no longer the next generation. They're here. It's the now generation of boards.
The EIPC was founded in 1968, but in fact, history is all about the people.
Having a look in the past with Paul, we look to the future. It's a computer smaller than a grain of salt. You can integrate it into consumer goods. It has blockchain capability. It only costs less than 10 cents. If you think this is science fiction or something, you will see it in the next 5 years.
Today I'm talking a little bit about thermal management. Our idea was to find something which is applicable to the production you already have. You can save all these process costs for extra adhesive, extra copper, and of course extra work.
I'm pleased to be chairing session 3.
The whole product portfolio comprises dry cleaning systems, diverters, turning systems, fully automatic, inline, standalone, DI, AOI automation systems, horizontal buffer systems, and multi-layer edge treatment systems. And I think it's a topic which will not disappear.
We have a new system where we use completely no belts at all. I mean, the whole buffer is just like a pick-and-place system where we have no belts and no moving parts where the panels are placed. A fully automated, integrated, data-driven PCB factory realizing a true single-piece flow. If I have a totally interconnected line like this, the yield will be quite high.
The total turnover is at 3.2 billion in 2017, so this makes our company the biggest company of PCB in the world. I have one example with me. This is the first generation. Basically, it's a single-side FPC.
So the key tests we do are flammability, bond strength, and delamination. I'm just going to try and give you some guidance on where we're at the moment and what the next steps are going to be. Recognised PCBs need to start being evaluated using appropriate sold limits, otherwise the PCB assembler is going to encounter problems. Currently, we've got a 2-year transition period identified from the time the formal communication is issued. We're not going to look at every single unique surface mount profile when we go and look at the assembler, and the amount of testing is going to depend on a lot of things.
Welcome back to the second half.
Today I would like to talk why we decided to develop the halogen-free material. And you have to remember that combustion process is a chain reaction, 3 methods to disrupt the combustion. That's why the reason we would like to introduce halogen-free material.
But it's interesting where our technology is today. I mean, could you imagine 50 years ago that we would have light bulbs with 16 million colors? We see this transformation of traditional devices into smart devices using some kind of a digital touch point. What's the value that your product brings, and how does that apply to the home, to the behavior of the customer?
So we have huge differences in insertion loss performance. First one was immersion silver, and you can see that that's a huge difference. Each new generation, the difference in insertion loss, in dielectric losses are getting smaller and smaller. If some folks think that the PCB has reached the limit of what can be done, I'm not agreeing to that.
How exactly do you measure that roughness? optical methods, either laser or white light measurement tools. It's actually, your question is a very good one.
Automatically also on the board again. And you can walk. They have a radar inside. Completely with all three lines that's operated.
Europe and Russia, we are both together.
I'd like you all to raise your glasses in the terms of the Michael Weinhold, the only man who has more gadgets than me.
Morning, ladies and gentlemen. I hope you had a good rest after yesterday's session. Time to marketing is essential today to bring your products into the market before your competitor do that. This is already reality in the supply chain of the PCB world.
The focus today of the presentation is about the digital integration of products, and this requires high layer count and HDI. Started in the automotive industry in Europe, but today smart factory and Industry 4 is all over the world.
The genesis of this work effort was, I guess for about the past year, everybody's been asking about 5G. For me, it was starting to sort of define where Flex fits into 5G. What does the market currently support, and then what do we actually need?
Moving from homes to smart homes, we see windows becoming smart, walls becoming smart, floors becoming smart. Every daily object of the future will contain electronic functionalities.
This is a roll-to-roll system. It's actually a rotary screen, and then we have a dry ink. And this is basically a PCB. And here we have an example, which is basically the rubber.
Integrate LEDs on flexible, stretchable, foldable substrates.
When you come here, you get to interact with different parts of the value chain, right? So you have fabricators, you've got OEMs, you've got suppliers, and you get a diversity of perspectives. So presenting your kind of knowledge and information to them, getting their feedback is valuable to the company. The technical exchange is very valuable just for the learning of the industry altogether.
New proportional land dimensioning concept.
So there is no proportionality in this extension to improve the manufacturing process of circuit boards.
Now we want to shrink the whole laboratory. This is a huge field. It's expanding a lot, at least research-wise. Commercially, it hasn't expanded yet. So why don't you know anything about it yet? We need to be educating people on what we have designed exactly and how this is a bit different from pure electronics.
PCB is actually all about communication. What is circuit data? New language for communication of article specification. Please join and help us to evolve this language.
I'm just wondering, where do the PCB got the energy from to work?
Batteries are printed by themselves also. Second option is, of course, energy harvesting.
You talked very briefly about silver inks. Can you tell me a little bit more about this?
This result was with one of the Mitsubishi inks that is now commercially available.
Concept for the calculation are the dimensions of the termination of the component.
I'd like to free you all for lunch.
About to start our last session. This session has topics about technology and production.
What we're all here for is solder joint reliability. By changing your rinsing technology, you can improve your high-speed shear testing. The faster you initiate your palladium, the better your high-speed shear testing.
The size of the microvias are shrinking and getting smaller and smaller. So we'd like to see as clean a hole as possible. So we look at the process of metallizing a microvia.
We need to start maintaining, design, embedded intelligence in the data, in the package, in the data set that we read in. We want to parameterize the world of optical inspection.
We come to these events to learn from what other people are doing as suppliers to the industry. We have, of course, competitors whom we're also interested in. We're interested to reach our audience, our customers, and definitely also a good part is networking.
Why inkjet for PCB? First, you have the cost reduction. UV curable inks you can use on a wide range of substrates, and we introduced that all in our latest development, in our solder mask inks.
An introduction into the inkjet printing process for applying a photomask to a PCB. We save machinery, we save floor space, we save maintenance costs, and we save personnel, which is quite important in terms of cost. You can use it as an additional protection layer for your base material and increase the lifetime of the PCB. That's a question that always comes, that the distribution of the jobs is simply changed.
The ink you are using is a special ink?
These are special inks developed for inkjet.
We are here to support the PCB community in Europe. And I'm so glad so many of you have come to the event. And of course, we'll carry on delivering high quality programs. So thank you so much for coming, and we'll see you next time. Thank you.